Hi, this is my cheap Mastercraft bandsaw from Canadian Tire, and it was worth every penny. That's because I got it for free. So the previous owner had the tire come off and it got shredded by the blade, and he tried to glue it back on, but with the high speed that these little things run at, it didn't stick, so he didn't have much luck with it and he just wanted to get rid of it. I really didn't want to invest in a tire for this saw, so first I ran the blade on just on the metal wheel, and that worked alright. Then I put some electrical tape on there, and that seems to work okay. Of course, I wanted to make sure the blade tracks on it just fine, so checking the wheel alignment, it seems as though the bottom wheel is a bit forward of the top wheel, and checking the top wheel alignment, the mechanism is a little bit iffy. So the top wheel slides up and down like this, and it's held in place with this bolt and a washer, and it used to be just a short screw in here. The problem is this screw needs to be a little bit loose for this part to move up and down, but there's nothing to lock this in place, so I could have put a little bit of Loctite in there to permanently fix that screw, but I didn't want to do that. So what I did instead is I got a much longer one, and that longer screw goes all the way through, comes out the back, and I just put a nut on there, and that locks that screw in place, so I can position it so it's always just snug with a tiny bit of play to allow it to have room, but it'll never come loose from vibrations. The bottom wheel of this saw is actually mounted directly on the motor, so it spins at about 1750 RPM, and that makes for a ridiculously fast blade speed, but obviously they were able to save a few dollars that way. But annoyingly, this bottom wheel has got a bit of wobble to it, so you can see it moving back and forth. Let's put the dial indicator on it. So you can see we've got about 20 thou worth of sideway wobble. That's about 0.5 millimeter, but that's really not that important. It's just a nuisance. But the problem is this wheel also has a wobble radially. So now I'm just measuring against the rim, which was machined along with the surface of this, and we see good 6 or thou 7 worth of variation in there. So this wheel is a little bit off center. And I've had this wheel off before and checked the shaft. The shaft wobbles by less than 1 thou. So most of this is actually that the hole and the rim are actually a little bit off center from each other. Now with this bottom pulley having a bit of a wobble like that, it's hard to check the wheel alignment like that. But overall, for different positions of this wheel, it does look like the top wheel should be brought forward a little bit. And certainly when I tack the blade on there, it always tends to be more forward on the top wheel. So either I bring the top forward a bit, which I can with these screws, but I don't want to bring it too much, or I could try tilting that bottom wheel like this a little bit by shimming the motor. To do that, I have to take the wheel off, but I have to do that anyways because when I had it off last, I only put it on temporarily and I didn't put the key back in. So I'm going to put the screw back in here just so that my gear puller has something to push against. And this has got 5 spokes on it, so maybe a 3-prong puller might be better, but I've pulled it off with this one before. It's a bit of a mess. And now with the wrench, I can just pull it off, and you can see it's coming already. And off comes the wheel. I'm also going to take the table off this saw just to give me a better view. So now I can loosen the screws for the motor. So the screw holes on here are about 4 centimeters apart, and the actual wheel center to center is about 40 centimeters, and I want about 3 millimeters worth of adjustment, so I need 1/10 as much for a spacer on here. This cut up plastic pop bottle is about 0.3 millimeters thick, so that's ideal. And so I'm just going to make some holes in here using a hole punch, and I need to punch several holes because the actual screw that needs to go through there is a bit bigger than the hole that this punches. So let's see, well, I can get the screw through here, so that spacer will do. So the tricky thing is putting these spacers in. They need to go against here, but if I just put them on the motor and then tilt the motor onto the mounting flange here, they'll just fall off, and there's no way to get them in there once I hold the motor in place. So what I'm going to do instead is I'm going to put the screws in here for starters, and then put the spacers on the screws so I will already have them in place. But even so, it's still kind of tricky to get this on, so hopefully I'm not going to have to do this twice. Well, I managed to get both of those in there, so success. So now checking that motor shaft, you can see the dial indicator moves back and forth by about a thou as I turn it. So this shaft has got a little bit of wobble to it, but that doesn't account for all the wobble that the wheel is seeing. And some oil on the rest of the shaft just to make it go on easier. Now let's put the pulley on, and I'm putting it partway on the keyway so that hopefully this will stay lined up. Now to pull this in, I'm just going to use a screw. Well, that was tough getting that on there, but now I can just loosen this out and back the screw out. And now put the proper screw in. Now let's see about that wheel wobble, if I can do anything about that. So first thing I'm going to do is I'm going to take my electrical tape tire off of here. So now with the dial indicator on the surface, let's see how it does. And it's about the same. So I'm going to try to machine that surface just a little bit. I'd also like it to have a bit more of a crown in it. So I've got a high-speed steel cutter from a metal lathe securely clamped in my vice grip. And I'm going to try to actually turn this a little bit freehand just by jamming that in there and trying to touch the wheel, see if I can machine it down a little bit. Well, that just put a little bit of gash in the side of the wheel. Fortunately not in the middle of the surface, so I think I'm still okay. Let's try that again. So, important safety lesson learned here. The way I held it on there initially, as soon as the wheel started pushing down there, that pushed the tool further in, and that's what caused it to jump like that and put the gash in the wheel. So always do as I say, not as I do. So with the tool held on like so, when the wheel pushed down on here, that pushes it out of there, which makes it stable, so that I don't get this sort of getting caught, and that seemed to work pretty good. So here's the gash that I put in at the beginning, and you can see on the surface there's a dark area here. This is where I haven't milled anything away because I didn't want to mill away too much. So basically the wheel was already a little bit lower here, so this part didn't get milled. So the important thing is when doing this sort of milling is to not hold the tool entirely freehand. I'm always touching it against the side here so that my tool doesn't start vibrating, so that I'm cutting nice and round on here. So let's check that wobble again. So we still have some left, maybe 2.5 thou, but that's as close as I'm going to get it on this band, so I think that's good enough. Half as much as it was before. Now my electrical tape is 7 thou thick, and I need to make sure I have the exact same number of layers of it all around, which is why I marked my starting point right here. And I need to wind it on the same way that the wheel turns, so that if the end of it comes loose, it's going to wind itself on and just flap around a bit, as opposed to unwinding and going catastrophic. And the tape is a bit wider than the rim, so I'm just making it go over the back flange and making it flush with the front one. It'd be too much trouble to try to cut this tape to width. Now I need to put more than one turn on, because with just one turn, this end could come loose and start undoing itself. As soon as I have more than one turn, that's no longer an issue, but I can't just put a turn and a half on here because of the tape thickness, so I have to put an exact even number of turns on the wheel. And I think this time I might go for 3 turns. I had 2 turns on it before. I can't tell you for sure that electrical tape is a good idea for a bandsaw tire, but I've run this saw a fair bit with just electrical tape on there, and that seemed to work. Again, I don't want to spend money on this saw, and a new tire would probably cost me 20 bucks. Okay, so that's the second turn now, because I'm back to my starting point. So now the third turn. And there's the mark again. So let's cut that right here. So there we go. No cost bandsaw tire. So now let's put the blade guide back on before I put the blade on, because that's impossible after. And let's see how that blade is going to line up. So I backed the blade guides way off, and I had to readjust the tracking, but it seems to be tracking fairly well now. So let's measure the wheel wobble again, this time on top of the blade and on top of my electrical tape tire. So I think I have about a total of 4th hour worth of variations. I think that's okay. So let's check that top wheel the same way. I'm just going to put this against here, rest it and against the knob, so hopefully it's steady. And again, I'm measuring against the blade. So it's quite bumpy up here because these tires are rarely very good. And we actually have a bit more variation on the top than we have on the bottom. So let's check that against my homemade bandsaw, and I've opened it up and I've rigged up the dial indicator up there. So I have about the same amount of variation on this one. And this is a wooden wheel that I turn by hand and an inner tube as a tire. But, well, this bandsaw is twice the size of this one, so relatively speaking, it's actually much better. Another easy way of checking if there's wheel wobble is to just see if the blade changes tension as it turns. So I'm just going to pluck this and turn it slowly. And you can hear the pitch going up and down slightly. This is more pronounced if I release the tension a little bit. And let's just spin this up. I've got the blade guides way backed off, so let's see how it runs. Reasonably smooth. With the blade tracking now, I can adjust my blade guides to that. This is a little bit of a silly design on this bandsaw. I need an Allen key to adjust the blade guides. And worse yet, I need different size Allen keys for the top and bottom. And these are very, very tiny little blade guides because it's a tiny little saw. And the thrust bearing can be adjusted laterally by rotating the shaft here. I'm just going to take the guard off here so you can see better what I'm doing. So these are at 45 degrees. I guess the idea is so it doesn't get in the way as much when you tilt the table. The thing about blades for these small bandsaws is they have to bend around a very tight radius. And bending a blade around too tight a radius puts a lot of stress on it and causes it to fail from metal fatigue. But if you make the blade thinner, then it's more flexible. So the blade on this saw measures 18 thou, and that's actually quite thin. Compare that to the blade that I've got on my 16-inch bandsaw, and that one measures 28 thou, so about 1.5 times thicker. So that makes the blade a bit more fragile, but you're never going to be doing any resawing with a bandsaw like that anyways, so it doesn't matter too much. Now let's put the table back on. The table only has one trunnion which screws against the back. Very simple design. And this is the handle for locking it on there, which is actually fairly solid. And when you pull on this, you can rotate the handle with respect to the screw. So it's a lot of back and forth, but if you put an Allen key in the middle and push, you can just turn that screw and it goes on a lot quicker. So the table is not quite 90 degrees to the blade anymore. So I'm just going to tilt that table. And there's a 90 degree stop in here, and if I loosen that nut on here, I can turn that screw in just a little bit. I still need to make an insert for this saw, and I made one out of this very thin material, but it's too light and it tends to bounce out, so I'm going to make a thicker one out of this material. It needs a little bit of sanding, but let's see now. Oh yeah, perfectly flat. So I drilled it out the back, and I'm just going to open that slot a bit more, just so that if somebody tilts the blade without removing this, it doesn't get kinked. So the blade that came with this saw has got almost no set, but that makes for a very fine cut compared to this cut with my other bandsaw, or this cut, which is just a bit thinner, that was cut with a Japanese dozuki. Of course, I can hardly cut any curves with this blade because it has so little set. So that's as tight a radius as I could cut with that blade. Well, this blade with almost no set to it actually makes for a very clean cut, even in softwood. Cleaner than this cut, for instance, which was done on my table saw. So this saw will just barely cut through 2 layers of the Baltic birch plywood, which is really important because that means you could use one of these saws to cut out the wheels for building a better bandsaw. Canadian Tire doesn't sell this particular bandsaw anymore. They've replaced it with a slightly bigger model with 9-inch wheels, and having a close look at that one, I think that one is a little bit better than this one. But in the meantime, well, this one was free. I don't think I'll be using it much in my shop, but it'll be handy for using it outside my shop.